Okay, now the lesson is electrochemistry. Electrochemistry is the lesson, ठीक है? And now the topic is degree of ionization, ठीक है? Degree of ionization, or it is also called degree of dissociation. Okay, degree of ionization or degree of dissociation, ठीक है? Now the degree of ionization or dissociation is designated by term alpha, ठीक है? It is designated by the term alpha, okay? And it is a fraction, okay? It is defined as the fraction, means how many electrolytes you have. It actually, this term is related to the ionization property, ठीक है? Weak acids or weak electrolyte or the strong electrolyte. We have already discussed the strong electrolyte and the weak electrolyte. That strong electrolytes are those which are completely ionizes, whereas the weak electrolytes are those which are not ionizes completely in the aqueous solution, ठीक है? So the degree of ionization, it is the fraction, means how many electrolytes are dissociated into ions, ठीक है? How many electrolytes are dissociated? How many electrolytes are dissociated into ions? So this is the degree of ionization, and it is a fraction. It is a fraction. It is designated by the alpha, ठीक है? It is the degree of ionization, as well as it is also known as degree of dissociation, ठीक है? So note it down. The fraction of total number of molecule. The fraction of total number of molecules of electrolytes. The fraction of total number of molecule of the electrolytes which ionizes in solution. Okay, which ionizes in solution. ठीक है? So for strong electrolyte, the alpha is almost equals to 1. ठीक है? For strong electrolyte, the alpha is almost equals to 1. ठीक है? Note it down. Whereas for weak electrolyte, the alpha is degree of ionization, ठीक है? Alpha is less than 1. Alpha is less than 1, because we know very well the strong electrolytes are completely ionizes, ठीक है? Whereas the weak electrolytes are ionizes to the small extent, ठीक है? They are not completely ionizes. Now the next topic is factors affecting electrical conductivity. Factor affecting electrical conductivity of electrolytic solution. Factors affecting electrical conductivity of electrolytic solution, ठीक है? Now here we have discussed the factors, ठीक है? The factors affecting the electrical conductivity of electrolytic solution. Okay. Now there are various factors. The first is nature of electrolyte. The first factor is nature of electrolyte. This is the first factor. Okay. The conductance of the electrolyte. Okay. The conductance of the electrolyte depends upon the nature ना. But nature means electrolyte का nature कैसे पता चलेगा आपको कि अच्छा electrolyte है? If it ionizes completely, ठीक है? Because for the conduction of electricity क्या चाहिए हमको? We require the ions ना. So the conductance of the electrolyte depend upon the number of ion. ठीक है? The conductance of the electrolyte depends upon the number of ions present in solution. The conductance of electrolyte depend upon the number of ions present in solution. Therefore, greater the number of ions, greater the number of ions, ठीक है, greater will be the conductance, ठीक है, greater will be the conductance, So this is how the nature of electrolyte affect the electrical conductivity, because the strong electrolytes are almost completely ionizes in the solution. It means they have good conductance. उनका conductance कैसा होगा? Good होगा, because they are completely ionizes into the ions. Whereas in case of the weak electrolyte, they are ionizes to the small extent. Therefore, their conductance is not good as compared to the strong electrolyte. ठीक है? So this is the first factor. Now the second factor is nature of solvent. This is the second factor. Nature of solvent. Nature of solvent. Electrolytes ionizes more in polar solvent. Electrolyte ionizes more in polar solvent. ठीक है? Therefore, greater the polarity of the solvent, larger is the ionization. ठीक है? It means greater the polarity. ठीक है? If the polarity is greater, तो definitely higher will be the ionization. Higher will be the ionization. ठीक है? So this is the second factor, is the nature of the solvent. Now the third factor is temperature. The third factor is temperature. The third one is temperature. This is the third factor which affects the electrical conductivity of the electrolytic solution. ठीक है? The conductivity of electrolyte depend upon the temperature. The conductivity of electrolyte depend upon the temperature. So with increase in temperature, with increase, the sign I have used for increase, okay, with increase in temperature, conductivity also increases. As the temperature increases, the conductivity also increases. And what is the reason? Due to decrease in, the reason is due to decrease in interaction between ions. The reason is due to decrease in interaction between ions. Due to decrease in interaction between ion is the reason why the temperature, with increase in the temperature, the conductivity also increases. Okay. Now let's come to the another topic, and the next topic is conductance. Okay, conductance is the next topic. Now conductance is the power. It is the power. Conductance is the power of electrolyte. Conductance is the power of electrolyte to conduct electric current. Conductance is the power of electrolyte to conduct electric current. Okay, and the conductance is also known as, it is also known as conductivity. Okay, conductance is also termed as conductivity. Conductance is also termed as conductivity. Okay, now there are few laws. Okay, because the magnetic conductor obey some laws. So the first law is, that is Ohm's law. Ohm's law. Ohm's law. Okay. The main concept of Ohm's law is I is directly proportional to V. Okay. This is the main concept, that is I is directly proportional to V. What is I? I is current. And what is V? V is potential difference. I is current and V is potential difference. The unit of I, what is the unit of current? Ampere. Ampere is the unit of current, and potential difference? Volt. Volt is the unit of potential difference. Okay. So Ohm's law is stated as Ohm's law. This is the Ohm's law. Ohm's law is stated as the current. This is the current flowing through the conductor. The current flowing through the conductor is directly proportional to I is the current. This is the current. Okay? The current flowing through the conductor is directly proportional to potential difference across it. Potential difference across it. Okay, and we can say that V is equals to IR. V is equals to IR. ठीक है, where R is the proportionality constant. R is the proportionality constant and it is known as resistance of conductor. ठीक है, it is known as resistance of conductor. ठीक है, R is the proportionality constant and it is known as resistance of conductor. ठीक है, it is expressed in ohms. The unit is ohms. It is expressed in ohms and it is represented by omega. ठीक है, it is represented by omega and it is expressed in ohm. ठीक है, so the above equation, this one equation. So the above equation is known as Ohm's law. So the above equation, this equation, we are talking about this equation. ठीक है, so the above equation, this equation is known as the Ohm's law. Now the Ohm's law may be stated as the strength of current flowing through a conductor. The strength of a current flowing through a conductor is directly proportional to the potential difference. Across the conductor. Okay. Now there are some more terms. Let us discuss these terms one by one. Now, the first term is resistance. This is the first term. Resistance. ठीक है? Resistance measures the obstruction. It measures the obstruction to the flow of current. ठीक है? Obstruction to the flow of current. So the resistance of any conductor is directly proportional to the length. ठीक है, the resistance R stand for the resistance. ठीक है, R stand for resistance. So the resistance of any conductor is directly proportional to the length and inversely proportional to the area of cross section. ठीक है, resistance is directly proportional to the length and inversely proportional to the area of cross section. So this one is resistance, this is length and this one is area of cross section. ठीक है, now if we remove the proportionality constant, that is क्या बनेगा, R is equal to rho L upon T. So this is the formula for the resistance, or by the help of this formula of the resistance we can find the value of the resistance. Okay, now that rho, this one is a Greek letter rho. ठीक है, this one is the Greek letter and is the constant of proportionality. ठीक है, this one is the constant of proportionality and it is called specific resistance or resistivity. ठीक है, this rho, this is a proportionality constant. It is called specific resistance. It is called specific resistance or resistivity. It is called specific resistance or resistivity. ठीक है? And its unit is ohm. And its unit is ohm. Okay, its unit is ohm. Now the next word is term is resistivity. Resistivity. Or resistivity is also called specific resistance. Resistivity or specific resistance. ठीक है? So the resistivity is defined as the resistance of a conductor. Resistivity is defined as the resistance of a conductor of 1 centimeter length and having the area of cross section is equals to 1 cubic centimeter. So here L is equal to 1 centimeter and A is the area of cross section. It is equals to 1 cubic centimeter. Or in other words, ठीक है, we can define it in another manner. That is, resistivity is the resistance between opposite faces. Resistivity is the resistance between opposite faces of 1 centimeter cube of the conductor. Of 1 centimeter cube of the conductor. Okay. Now the next term is the conductance. We have already discussed the conductance. Now come to the next one, that is conductivity. Okay. Conductivity. These are the common terms. Okay. Conductivity. This is the next term, that is the conductivity. It is the inverse of resistivity. Inverse of resistivity. ठीक है? So the inverse of resistivity is called conductivity. ठीक है? Or it is represented by a symbol kappa, that is K is equal to A. This is the representation for the conductivity. K, small k, kappa. Okay, this is the representation for the conductivity, and it is defined as the conductance of a solution. The conductivity is defined as the conductance of a solution of 1 centimeter length and having 1 square centimeter cross section area. ठीक है? और K is equal to 1 upon rho. Okay, and its unit is per ohm per centimeter. Per ohm per centimeter is the unit of conductivity. ठीक है? Per ohm per centimeter is the unit of conductivity.